Welcome to this lesson on algebraic expressions and identities. In this session, we will explore key concepts including expansion, factorization, and algebraic identities. Let's get started. In this lesson, you will understand the basics of algebraic expressions and identities. Learn how to expand and simplify expressions using algebraic identities. Discover effective techniques to factorize algebraic expressions. Apply these methods to solve mathematical problems step by step. An algebraic expression is a combination of numbers, variables, and arithmetic operations. For example, expressions like negative 2x plus 3yy minus 5 or negative x squared minus 4x plus 7 are algebraic expressions. Algebraic expressions consist of different components, terms, each part of an expression separated by an operator. For example, in 3x plus 5y, the terms are 3x and 5y. Coefficient, the numerical factor of a term. In 4x, the coefficient is 4. Constant, a term without a variable. In x squared plus 3x minus 7, the constant is negative 7. There are three main types of algebraic expressions. 1. Monomial, a single term such as 5x or 3y squared. 2. Binomial, an expression with two terms like x plus 3 or a squared minus 4b. 3. Polynomial, an expression with multiple terms such as x cubed minus 2, x squared plus x minus 1. Expansion is the process of removing parentheses by distributing multiplication over addition or subtraction. This follows the distributive property. A times the sum of b and c equals a times b plus a times c. For example, expanding a plus b times c plus d gives a times c plus a times d plus b times c plus b times d. Let's apply the distributive property to expand the expression. First example, we start with the expression 3 times x plus 2. Using the distributive property, we multiply 3 by x, which gives us 3x. Then we multiply 3 by 2, which gives us 6. So the expanded form of this expression is 3x plus 6. Second example, now let's expand x plus 3 times x plus 2. Using the distributive property, we distribute x to both terms inside the second bracket. X times x gives us x squared, and x times 2 gives us 2x. Next, we distribute 3 to both terms inside the second bracket. 3 times x gives us 3x, and 3 times 2 gives us 6. Now, combining all the terms, we get x squared plus 2x plus 3x plus 6. Finally, we simplify by adding 2x and 3x, which results in x squared plus 5x plus 6. This process is called expanding an expression using the distributive property, which helps us rewrite expressions in a more simplified form. Factorization is the reverse process of expansion. It involves rewriting an expression as a product of its factors. This is useful for simplifying expressions and solving equations. A simple example is factoring ab plus ac, which gives a times the sum of b and c. Consider the quadratic expression x squared plus 5x plus 6. We need two numbers that multiply to 6 and add up to 5. These numbers are 2 and 3, so we can factorize the expression as x plus 3 times x plus 2. Now let's factorize 6x plus 9 by taking out the greatest common factor. The highest common factor of 6x and 9 is 3. Factoring it out, we get 3 times the quantity of 2x plus 3. We explore important algebraic identities, equations that hold true for all values of variables. First identity, the square of the sum of two terms. The expression a plus b squared expands to a squared plus 2 times a times b plus b squared. This follows from multiplying a plus b by itself and applying the distributive property. Second identity, the square of the difference of two terms. The expression a minus b squared expands to a squared minus 2 times a times b plus b squared. The negative sign in the middle term appears because we are multiplying negative b by a and negative b by itself. Third identity, the product of the sum and the difference of two terms. The expression a plus b multiplied by a minus b simplifies to a squared minus b squared. This identity results from expanding the expression and noticing that the middle terms cancel out. These fundamental identities are essential for algebraic simplifications and problem solving. Let's apply the algebraic identities we learned with some concrete examples. First example, let's expand 3x plus 4 squared using the identity for squares of binomials. Using the identity for the square of a sum, we expand it as follows. 3x squared gives us 3x squared. Then 2 times 3x times 4 results in 24x. Finally, 4 squared gives us 16. So the expanded form is 9x squared plus 24x plus 16. Second example. Now, we take the expression 2y minus 5 squared. Using the identity for the square of a difference, we expand it as follows. 2y squared gives us 4y squared. Then 2 times 2y times negative 5 results in negative 20y. Finally, negative 5 squared gives us 25. So the expanded form is 4y squared minus 20y plus 25. Now, let's apply the difference of squares identity to factorize x squared minus 9. Recognizing it as a difference of squares, we can factor it as follows. X squared is simply x times x. 9 is 3 squared. Using the identity, we factor it as x minus 3 times x plus 3. Now, we take the expression 4y squared minus 25. Again, we recognize it as a difference of squares. 4y squared is the square of 2y. 25 is the square of 5. Using the identity, we factor it as 2y minus 5 times 2y plus 5. This method is useful in simplifying and solving algebraic expressions efficiently. Now, it's your turn to practice. Try solving these problems. 1. Expand 2x minus 4 squared using identities. 2. Factorize x squared minus 25. 3. Expand y plus 6 times y minus 2. 4. Factorize 9x squared minus 16. 5. If the area of a square is given by x plus 3 squared, express the area as a sum. That wraps up our lesson on algebraic expressions and identities. We covered expansion, factorization, and important algebraic identities to help you simplify and solve expressions like a pro. Now it's your turn. Try solving the practice problems and apply what you've learned. If you found this video helpful, don't forget to like, share, and subscribe for more math lessons. Got questions? Drop them in the comments, and I'll be happy to help. See you in the next lesson. Keep learning, keep practicing, and keep excelling in math.